Hello everyone. This is the final update on my 6502 computer for the semester. As you can see, I kind of cleaned it up a little bit. I used some Ethernet cables to get rid of some of that excess wire and just kind of make it look a little bit nicer. Another thing you may notice is I added in another chip here with some LEDs. Now, the chip that I added in is a 65C22 versatile interface adapter, which allows my 6502 to have general purpose I/O functionality. So the the chip allows me to have, of course, general purpose I/O pins. So just kind of pins that I can switch on or off. Those are done through 2 registers on the chip. But it also has 2 timer counters on it. I think at least one is 16 bits. I can't remember if the other one is 16 bits or not. And it also has shift register functionality, which of course allows me to shift data in and out of the chip. So yeah, it provides a pretty wide range of I/O functionality. And it's implemented as just part of the memory map of the system. So I have the chip plugged in, the 65C22 plugged into the lower 4 bits, first of all, of my address bus. And the memory decoding logic decodes the 65C22 into the B4 XX range of addresses. So the very first register would be accessed on B400. And then it moves on from there for the digital I/O in the memory map. Now, the reason why it's tied into the lower 4 bits of the memory range is because the 65C22 has 4 pins that access the different control registers on the chip. So for example, if I wanted to set up one of the output registers to be all outputs, well, one of the input-output registers to be all outputs, I would have to access that register through all 4 bits on the device and then write my data to that. That I would be able to set up I/O that way. And right now, to just kind of demonstrate the digital I/O functionality of the computer, I have it running a very basic assembly program for a Larson scanner. So, as you may have noticed throughout the video, the LEDs have been shifting forward and backward very slowly throughout the course of me talking. Now, of course, a Larson scanner is just a row of LEDs that scan back and forth. Very, very simple, and a great way to demonstrate I/O. Usually, Larson scanners move a bit faster than what it is right now. But in my case, my computer is only running at 1 hertz, and it takes several instructions before it can actually output to an LED. So it runs very slowly. If I had my computer running at a faster speed, it would be a little bit more fun to watch. But as is, it's a good demonstration of my I/O chip working. So yeah, that's where the project is at right now. With digital I/O implemented and with the memory map implemented, I should be able to add in a bunch more functionality later on down the line. But this is where I'm going to be stopping for the semester. I/O will allow me to add in a bunch of different, just kind of general purpose interfacing devices. So I could use, let's say, an audio chip, an LCD character screen, different things like that. I can interface through the I/O chip. And then the memory map would allow me to implement things like video, serial communications and different ways to kind of display what's going on the computer. So that means I can get rid of this guy right here, and I've already gotten rid of the data bus display just because it was getting messy and I needed another EEPROM off of it. So got rid of that. But yeah, that's where the project is. Thank you guys for keeping up to date with it and watching me as I've been moving along.